Dear students, last class we discussed few problems on Lagrange's interpolation and Lagrange's inverse interpolation formula. Today I am going to discuss one more problem on the same method, but it's a different type of problem. Observe the problem statement here. Use Lagrange's formula to fit a polynomial for the given data. And hence we need to find out the value of y when x is equal to 2. So here finding y is not an important issue. We need to find a polynomial which satisfies the given data. That is very important by using Lagrange's interpolation formula. As usual, first consider the given data. Mention the values, that is x0, x1, x2, x3, similarly y0, y1, y2, y3, everything. This I consider only for reference, no need to write this again and again. After consider the given data, as usual, I told you already, first we need to find a polynomial. For that, first consider the Lagrange's interpolation formula. And now, remember, when we are finding a polynomial, we are not supposed to replace x in the formula. So observe here, I replace all the values, means I replace the x1 by 1, x2 by 3, x3 by 4, y0 value, y1 value, y2, y3 and everything except x. So this is the difference between the previous type of problem and this type of problem. So here I am finding a polynomial. So in the formula I will keep x as it is. I won't replace anything and replace the remaining given data. And now observe term by term along with this formula x minus a, x minus b into x minus c. First I will consider this term. I will explain this. Observe carefully. Forget about this minus 12 and the denominator. Here is minus 12 and here minus 1 into minus 3 into minus 4 gives minus 12. So I consider that here. Now concentrate on the numerator, x minus 1 into x minus 3 into x minus 4. This is similar to x minus a into x minus b into x minus c. So here a is 1, b is 3 and c is 4. Now according to this formula, first consider x cube. Now minus x square into a plus b plus c. According to that, here a is 1, b is 3, c is 4 plus x into ab plus bc plus ca means a into b, that is 3 into 1, and then b into c means 3 into 4, and then c into a means 4 into 1 minus abc. So minus 1 into 3 into 4, that gives 12. So this is the product of x minus 1 into x minus 3 into x minus 4. Is that clear? By using this technique. Now the remaining is minus 12 divided by minus 12. I consider that here. Similarly, observe this here. 0 by 6 here. Minus 3 into minus 2 into 1, that gives a 6. But the advantage is we have a 0. We are multiplying everything by 0. So no need to bother about this term. Now the third term, 6 divided by 3 into 2 into 1, so 6 by 6. Okay, here minus 1, so 6 by minus 6. Now this term, x minus 0, x minus 1, x minus 4. So repeat the same technique here again. So first consider x cube. So this. Now minus x square into a plus b plus c. Here a is 0, b is 1, c is 4 plus x into ab plus bc plus ca. So a into b means 0 into 1 is 0. Next b into c means 1 into 4 is 4. And then c into a means 0 into 4 is 0. So minus abc. So minus abc is nothing but 0 into 1 into 4, that gives 0. And then this remaining 6 by 6. Okay. Now similarly apply the same technique for the last term. After applying that, now your work is collect the coefficient of x cube from the complete. This is one expression. These 4 line, 1 expression. Line 1 represents the first term, line 2 represents the second term, this line 3 represents the third term, and the fourth line represents the fourth term. So this is complete one expression. Now in this expression, collect the coefficients. First collect the coefficient of x cube. So x cube into 12 by 12 gives 1, so 1. Next x cube into 0, 0 by 6 is 0, so 0. I won't consider that here. Next x cube into 6 by minus 6 gives minus 1, so I consider that here. X cube into 12 by 12 is 1, so I consider that here. Similarly, collect the coefficient of x square. When you are collecting the coefficients, here x square into 1 plus 3 plus 4 means 8 into this, 7 into this, 5 into this, 4 into this. So remember that. Okay, this is also multiplied to each term. Similarly, collect the coefficient of x and collect the constant term. That gives a polynomial. If you want to verify, replace x is equal to 0 in this polynomial. What happens if you replace x is equal to 0? Y of 0 is equal to minus 12. So this is the first data given. When x is 0, y is equal to minus 12. Now if you want replace one more, you can check one more value. Replace x is equal to 1. What happens if you replace x is equal to 1? 1 minus 7 plus 18 minus 12. So this gives 19 minus 20, 19 minus 19. Okay. So 1 minus 7 is minus 6, minus 6 minus 12 is minus 18, plus 18, 0. So this gives the second data. Similarly, if you want, you can replace these values also. You can verify that. So this is the procedure to find the interpolating polynomial. So for that purpose only, I'm using this x minus a into x minus b into x minus b technique. So this is the required polynomial. So be careful when you're going to apply the product of 3 factor. Use this technique easily. You can multiply the 3 factors. Now the next part is we need to find the polynomial. That part is over. So this is the required polynomial. We need to find out y when x is equal to 2. It's nothing but in the given polynomial, you got some polynomial. Here replace x is equal to 2. Now to find y at x is equal to 2, replace x is equal to 2 in this polynomial. You will get the required answer. So this is the procedure of finding a Lagrange's polynomial or interpolating polynomial by using Lagrange's interpolation formula. I explained one more problem here. You can use the same technique, and this problem I explained completely here, the same procedure, and the answer is given. You can verify this, and the same procedure, you can use the same technique to solve this problem also. This is a very, very important problem. Sometimes they may ask find the interpolating polynomial. So then use this technique. Thank you.